Now this video is going to show you how to complete the problems on page 33 out of your math book. So in previous lessons, you learned that when the outcomes in a sample space are equally likely, the probability of an event is the number of outcomes in the event divided by the number of outcomes in the sample space. So what that really means is you're used to seeing spinners and stuff where it's like a beautiful circle and each of the sections are equally likely to happen. And pretend that these are all equally likely to happen because pretend they're all the same size, okay? So you're used to something like that, okay? However, when the outcomes in the sample space are not equally likely, we need to take a different approach. So that would be something like this if I had a spinner and it was something like that, okay? Where this was more likely to happen than this, all right? And they're going to present this type of thing in a table. So when Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. So this Jenna girl is really bananas because she really keeps track of all this sort of stuff. So the number of bananas, for her to buy 0 bananas, the probability of that happening is 10%, or 0.1 as a decimal. The probability of her buying 1 banana, that's a 1/10% chance of happening, or 1/10 as a decimal chance of happening. Right here, for her to buy 2 bananas, that would be also a 1/10 chance of happening. And for her to buy 3 bananas, that's a 2/10 chance of happening. For her to buy 4 bananas is also the same as that one. And for her to buy 5 bananas, that looks like it's most likely to happen because she's got a 3/10 chance of that happening, okay? Now you'll notice that, remember the probability scale goes from 0 to 1? Well, when you add these guys right here together, that's what? 3/10 plus 2 more is 5/10 plus 2 more, or 2/10 more is 7/10 plus another 3/10. That gives me 1 whole. So you'll see that these probabilities right here, they'll add to 1. Similar to up here, when I add this right here with this, that would be 1 whole, okay? So their probabilities will always equal 1 whole because you don't have a probability that's bigger than 100% chance of happening. So these will always add to 1 when you have a situation like this, okay? But anyway, it's asking what's the probability that Jenna buys exactly 3 bananas? Okay, so I gotta look, okay, number of bananas, 3. Oh, that's not 3, that's 3. So 2/10 chance of happening, which is 20%, okay? The next one, what's the probability that Jenna does not buy any bananas? So probability 0 bananas is 1/10, which is 10%. You know, I can also write these as fractions. So this is 2/10. See, say it out loud, 2/10, 2/10. I can simplify that down to 1/5. This right here is 1/10. That's very simplified, okay? What's the probability that Jenna buys more than 3 bananas? So let's look. Hey, are you more than 3 bananas? Nope. Are you more than 3 bananas? Nope. Are you more than 3 bananas? Nope. Are you more than 3 bananas? No, I'm exactly 3 bananas. Okay, so you're more than 3 bananas and you're more than 3 bananas. So we would have to add these probabilities together. So 2/10 plus 3/10. You can write them like this, or you can write them like this as a fraction. Hard to see, sorry. So 2/10 plus 3/10 is 5/10, or 2/10 plus 3/10 is 5/10. Well, 0.5 as a percentage is 50%. 5/10, 5 divided by 10 is 0.5, which is 50%. So either one of those works, okay? All right, what's the probability that Jenna buys at least 3 bananas? Okay, so again, I'm going to talk to my paper. Hey, are you at least 3 bananas? Nope. Are you at least 3? Nope. Are you at least 3 bananas? Nope. Are you at least 3 bananas? Yep. Hey, are you at least 3? Yeah. Are you at least 3 bananas? Yep. So we gotta add 2/10 plus 2/10 plus 3/10. Oops. Sorry. That's a 3. Okay. So this right here, that's 4/10 plus another 3/10 more, which would give me 7/10. All right, 7/10 like that if you want, which would also equal 7 divided by 10 is 0.7 or 0.70, which is that 70%, okay? Okay, what's the probability that Jenna does not buy exactly 3 bananas? So does not buy exactly 3. Probability of not exactly 3, okay? So I'm going to talk to my paper again. Are you not exactly 3? Yeah, I'm not exactly 3, so I'm going to include you. Are you not exactly 3? Yep, so I'm going to include you. Are you not exactly 3? Yep, so I'm going to include you. Are you not exactly 3? Oh, you are exactly 3. I don't want you. Hey, are you not exactly 3? Yep, so we can include you. Are you not exactly 3? Yep, so we can include you. Okay, so when you add 1/10 plus 1/10 plus 1/10 plus 2/10 plus 3/10, you should get 8/10. And that would be 80% as a percentage. Or if you want it as a fraction, 8/10, which simplifies down to divide by 2, divide by 2, 4/5. 4 divided by 5 is 0.8. It all works out. These are all acceptable. Okay, this down here is super important, and I think I've already talked about this, but here's what they officially say out of your book. Notice that the sum of the probabilities in the table is 1 whole. See all this junk from the table right there? Hey, I already told you that. That equals 1. This is always true. When we add up the probabilities of all the possible outcomes, the result is always 1. So taking 1 and subtracting the probability of the event gives us the probability of something not occurring. So they're relating that to this right here. So another way that you can do this, instead of talking to your paper like your teacher, is like this. You know that they all add up to 1, right? So you go 1, and then you'd subtract the one you don't want, because we don't want exactly 3 bananas. So we gotta subtract 2/10. So 1 minus 2/10. So 1 minus 0.2 is 0.8, which is 80%. Exactly the same thing right here, okay? So if this is kind of weird to you, do this one. If you don't like this, do that.